In this video, we're going to revise how to solve some simple equations. And in the process, we shall see how expansion is used. First of all, let's consider the concept of solving equations and how that differs from the professional approach that we demonstrate when we write out our solution. So what is the concept? The concept of solving an equation is basically isolating x, i.e. making x the subject, i.e. finding an equation that says x equals whatever, and you do that by doing the same thing on both sides of the equation. And that is necessary because you want to maintain the balance. For example, if 5x is equal to 20, how do we isolate x? Here, x is multiplied by 5, so we have to cancel the multiplication by dividing by 5. So the concept is that we are saying that we're dividing this side by 5 and this side by 5, giving us x equals 4. However, this is rather messy, and the professional way is to say that 5x equals 20, immediately go to x equals 20 divided by 5, which equals 4. So don't write this here, even though this is the concept. Similarly, if x plus 5 equals 12, what is x? Now x is added to 5. So what cancels addition is subtraction. So you would find people saying subtract 5 from both sides of the equation. So 5 minus 5 cancel out, giving you x equals 12 minus 5, which is 7. Now, even though this is the concept, it also looks messy and unprofessional. And notice that what happened here, it's as if the plus 5 moved to the other side, but changed its sign. So, if you wanna solve this in a more professional way, you would say, okay, I need to subtract 5 from both sides. When I subtract 5 from the left-hand side, the 5's cancel out, and I'm left with 12 minus 5, which is 7. This is a linear expression equal to another linear expression, and we need to work with the professional way because otherwise it'll be too messy. Rearranging this equation, we bring the x terms to one side and the constants to the other. But every term, if I want to bring it to the other side, I have to change its sign, as we have just seen. So this becomes 3x minus 2x, bringing the 2x to the left-hand side, equals the negative 3, still here, but the 4 comes to this side and it becomes negative 4. So 3x minus 2x is x, and it equals to negative 3 minus 4 is minus 7. Now what if you decide to move the terms to the other side? Let's take the constants to the left-hand side. On the left-hand side, I have a 4, and if I move the negative 3 to the left-hand side, that is adding 3 to both sides, becomes 4 plus 3, equals, we have the 2x on the right-hand side, and we need to bring the 3x to the right-hand side, and we have to change its sign. This gives us 4 plus 3 is 7, equals 2x minus 3x is negative x, and in this case, x is not the subject. I don't need negative x, I need x. So I have to multiply both sides by negative 1, and this gives me negative 7 equals x. And it's a better way to answer x equals negative 7. Now if you look at this equation, it's obvious that we will need to expand because we want to isolate x. And here we have 5x, but it's multiplied by 3. We have 4x here, but it's multiplied by 2. So we expand first. 3 times this quantity gives us 15x minus 12 is equal to, expand this bracket, 8x minus 2. Now collect the x terms on one side. Let's say we want to collect them on the left hand side. We have 15x minus 8x equals negative 2 plus 12. This gives us 7x equals 10, and so x equals, dividing both sides by 7, 10 over 7. Note that the solutions do not contain your thought process. And note that also each line is made up of an equation. You don't need to put equal signs here. This is absolutely wrong, because an equation cannot equal another equation. In this case, let's think of a shortcut. And of course you can do this by expanding and simplifying and following the same process as before, but let's see if we can do it in a quicker way. Mentally, this is 2x and this is minus 8x. So 2x minus 8x is minus 6x. 2. And this is 20. Minus 4 times minus 5 is 20. 2 plus 20 is plus 22. Equals, expand, 6x minus 18. Now I notice that if I take the 6x term to the left hand side, I will end up with a negative coefficient of x. So I may decide to bring the negative 6x to this side. So I have a 6x, which is this one, and I take this term to the other side, and it's plus 6x. I have a 22 here, and the negative 18 comes to this side, it becomes a plus 18. So this is 40 equals 32x, 12x. Therefore, x equals 40 divided by 12, which is 10 divided by 3. Now, when we have fractions and we want to isolate x, it's better to get rid of the denominators. Now, what will get rid of the 3 and the 4? It's simply multiplying both sides by the lowest common multiple of 3 and 4. So I multiply this by 12, and I multiply this by 12. Now, it's very important to remember that you have invisible brackets in algebraic fractions. So you basically have a bracket here, even though it's not written. But when you do this multiplication, look what happens. The 3 cancels with the 12, giving us a 4. And the 4 cancels with the 12, giving us a 3. So it seems that x over 3 equals, let's write the invisible brackets, 2x plus 1 divided by 4 simply became 4x equals 3 times 2x plus 1. So conceptually, what happened was we multiplied both sides by the lowest common multiple of the denominators, but what appeared to be happening is that it's as if we cross-multiplied. The 3 was multiplied by this bracket, and the 4 was multiplied by x. So cross-multiplication is a quick way that will allow us to solve fractional equations. This is 4x equals 6x plus 3. And let's say we take the 6x to the left-hand side, even though it will give us a negative coefficient. Mentally, you can see that it becomes negative 2x equals 3, and therefore x equals negative 3 over 2. Remember, this can be written as negative 3 over 2, or 3 over negative 2, or negative 3 over 2. They're all the same. This is another example to stress the idea of the invisible brackets. We have one fraction here, one fraction here. So we can cross multiply. Cross multiplication gives us 3 times x plus 1 inside brackets, remember the invisible brackets, equals 5 times x minus 2. This is 3x plus 3 equals 5x minus 10. And if we take the constants to the left hand side, can you see that it's 13 equals 2x? Mentally, you can do that. And therefore x equals 13 over 2. However, we have a word of warning. Cross multiplication can only be done if we have two fractions, one on either side of the equal sign, such as this case. We have a fraction equal to another fraction. We don't have any extras here nor here. That's the only case where we can do cross multiplication. Now, for the final example, remember that the negative 7 over 2 can be thought of as negative 7 over 2 or 7 over negative 2. So when we cross multiply, we decide where we want to put the negative sign. For the case of this example, let's choose this. Cross multiplication will give us negative 2 times 2x plus 5 is equal to 7 times x minus 3. Because this negative 2 was multiplied by this numerator and this 7 was multiplied by this denominator. Expand. Equals 7x minus 21. Collect the x terms, let's say on the left hand side. We get negative 11x equals negative 11. So x equals negative 11 divided by negative 11, which is 1. Remember, negative a over b equals negative a over b equals a over negative b. And I'll leave it as an exercise to you to prove that if you use negative 7 over 2, you will get exactly the same answer.